Have you ever pondered on the sheer complexity and power of the human brain? How it effortlessly performs calculations and processes information at lightning speed? What if our computers could mimic this remarkable organ? Enter the world of neuromorphic computing. Neuromorphic computing is a fascinating field where technology draws inspiration from biology. It's essentially an approach to computing that is inspired by the structure and function of the human brain. Imagine a computer or a chip that uses artificial neurons, much like our brain's neurons, to carry out computations. This is the crux of neuromorphic computing. In recent years, the term neuromorphic has broadened. It now envelops analog, digital, mixed-mode analog-digital VLSI, and software systems that implement models of neural systems. These systems could be used for perception, motor control, or multisensory integration. But how do we realize neuromorphic computing on a hardware level? The answer lies in a variety of components, including oxide-based memory stores, spintronic memories, threshold switches, and transistors. Combining these elements, we can create hardware capable of mimicking the human brain's function. Moving over to software, training neuromorphic systems of spiking neural networks is achievable. We can use error backpropagation with Python-based frameworks such as SNNTorch. Alternatively, we can use canonical learning rules from the biological learning literature using tools like BindsNet. A central aspect of neuromorphic engineering is the understanding of how the morphology of individual neurons, circuits, applications, and overall architectures create desirable computations. It's about how information is represented, how the system remains robust to damage, how it incorporates learning and development, adapts to local change, known as plasticity, and facilitates evolutionary change. Neuromorphic engineering is a multidisciplinary subject. It draws inspiration from biology, physics, mathematics, computer science, and electronic engineering to design artificial neural systems. These could be vision systems, head-eye systems, auditory processors, and even autonomous robots. The physical architecture and design principles of these systems are based on those of biological nervous systems. This concept was first proposed by Carver Mead in the late 1980s. In summary, neuromorphic computing is a field where technology and biology intersect. It involves creating hardware and software systems that mimic the structure and function of the human brain. From perception to motor control, these systems hold immense potential for the future of computing. And with an understanding of individual neurons, circuits, and overall architectures, we can engineer systems that are robust, adaptable, and capable of learning and development. Neuromorphic engineering, a multidisciplinary subject, is leading the way in designing these artificial neural systems, paving the way for a future where our computers might just be as complex and powerful as our brains.